Hello and welcome to this video on the ideal gas law and its application to determining or calculating volumes of gases. I'm just going to read the subtitle up here on the whiteboard. The ideal gas law allows us to express the amount of a gas as moles or volume, which is a handy capability for exposure assessment, environmental health, and science in general. So let's get into this. This is a what I'm going to show you here is a input to calculations that we'll do in a separate video. Calculations that show us how to go from the concentration of a gas in mass per volume to mixing ratios, or the other direction. Alright, but let's just start here with the ideal gas law. So as you probably remember from other coursework or work experience, the ideal gas law can be written like this: PV equals nRT, where P is pressure. I recommend using units of atmosphere. Now, V is volume. I recommend using units of liters. T is temperature. This is absolute temperature, so it's in volume, units of Kelvin. N is the number of moles. And then R is the ideal gas constant. You may remember that the ideal gas constant is exactly what it sounds like. It's a fixed value. Here are numerous units and corresponding numbers can be used for the universal gas constant or the ideal gas constant. There are many, as listed at a website called the Engineering Toolbox, which is kind of a handy tool. I recommend, for our purposes, using this form of the ideal gas constant: 0.0082057,338, and the units of that are atmosphere liter per mole Kelvin. I'm just going to copy this number over to our whiteboard and just going to stick it. Going to put it right here for just so we have it for later use. Maybe I'll just drop it down here. 0.082. Go back to the pen. 0.082 liter atmosphere per mole Kelvin. Alright, so we want to use the ideal gas law to understand the relationship between the number of moles of a gas and the volume of the gas. So to do that, let's rearrange the equation solving for volume. So that would be V equals nRT over P. Great. So now let's calculate the volume of 1 mole of a gas at a given temperature and pressure. So I'm going to write it this way: volume 1 mole. And I'm going to say, let's do it at 25 degrees Celsius and 1 atmosphere of pressure. So 25 C in 1 atmosphere is what's known as normal temperature and pressure. It's a very standard condition. We'll use it often in future exercises, so that's why I chose it here. So let's go ahead. So we can fill in for nRTP. So we have 1, my bad, not an atmosphere, it's a mole. All right, 1 mole. And now let's put in the gas constant, 0.082 liter atmosphere. Let's go ahead and put the mole Kelvin in the denominator where they belong. And temperature will be 298 Kelvin. And remember, Kelvin is just, to go from Celsius to Kelvin, it's 273 plus the Celsius degrees. And then we have divide through by the pressure. We're doing this at 1 atmosphere. All right, we've got N, we've got R, we've got T, and dividing through by 1 atmosphere. Let's examine the units here, cancel out where we can. Atmosphere in the denominator and the numerator, Kelvin in the denominator and the numerator, moles in the denominator and the numerator. So if we pull out our calculator and we use not 0.082 but the full string down here, 0.082057338 for the gas constant, and multiply that by the 298 Kelvin, we will get 24.45 liters. What does that mean? It means 1 mole of gas at 25 degrees Celsius in 1 atmosphere, in other words normal temperature and pressure, has a volume of 24.45 liters. This is a very standard value in environmental science, exposure assessment, environmental health, science in general. I recommend memorizing this number. We'll use it again and again. You will use it over and over again as you progress in your career. All right. So that's an introduction to the ideal gas law and how it can be used to express volumes of gases. We find it useful, and I know we're going to use it once more.